Let's see eighth question, dear students. Already this eighth question we are discussed in level 2 only. What is that? Free radical substitution reaction. So it is a bromine is heated in the presence of sunlight. So alkanes reacts with halogens in the presence of sunlight. It belongs to free radical substitution reactions in which the intermediates are more stable free radicals formed as intermediates. Let's see this para-ethyl nitrobenzene. Here it is benzylic carbon or benzylic position. Benzylic position. Okay. Now the halogenation will takes place at benzylic carbon. The product is here bromine will forms and para position nitro as it is. If you observe that this is a chiral carbon or asymmetric carbon. Why it is chiral carbon or asymmetric carbon? Bromine and CH3 and phenyl and hydrogen. 4 different groups are present. Now the resultant product is D and L mixture. So here 2 types of isomers will form. It exhibits optical isomerism. It shows optical isomerism. So how many optical isomers or enantiomers will form? Number of enantiomers. Number of enantiomers, how many will form? 2 will form. Why 2 enantiomers are present? Because one asymmetric carbon is present or one chiral carbon is present. The number of optical isomers, how many? 2. Because number of optical isomers or enantiomers formula is 2 power n, where n indicates the number of chiral carbons or number of asymmetric carbons. Okay, so that here they are not asked how many, whether it is optical, the product is optically active or inactive, just what is the product they are asked. So the answer is second option. So the halogenation is taking place at benzylic carbon. This is known as benzylic carbon or benzylic position. Okay. Now let's see for ninth question. Ninth question also we are discussed. Just one bromocyclohexane treated with magnesium metal in the presence of dry ether forms Grignard reagent. MgBr. This is on hydrolysis. Hydrolysis means reacts with water. Water is a proton source, proton donor. Then this cyclohexane abstract this proton forms the final product is cyclohexane. Okay. This is all. This question also repeated in level 2. Okay, let's go for 10th question. Tenth question. It's very easy. This conversion. Alcoholic KOH. Alcoholic KOH means elimination reaction. 10th one. Alcoholic KOH means 2-bromopropane. CH3 CH Br bond CH3. Okay, treated with alcoholic KOH means loss of dehydrohalogenation, HBr. This halogen attached carbon we are considered as alpha carbon. The next year beta hydrogens are present, beta carbon, 2 sides. Whether the right side if you are removing that beta carbon or left side you are removing the hydrogen atom from beta carbon, produce same type of product, that is propene. CH3 CH double bond CH2. Propene is the product. This propene is treated with HBr in presence of peroxides. In presence of peroxides or peracids. Peroxides, it is belongs to anti-Markovnikov addition reaction. Anti-Markovnikov addition reaction. Anti-Markovnikov addition reaction is free radical addition reaction. Free radical addition reaction. Okay, students. Free radical addition reaction, anti-Markovnikov addition reaction. Now It is a hydrogen atom added at less number of hydrogens containing carbon, and halogens are added at more hydrogens containing double bonded carbon. The product is CH3, CH2 bond CH2 Br. Okay, 1 bromo propane will forms. Then this is treated with sodium iodide, acetone. Sodium iodide in the presence of acetone means Finkelstein reaction. Finkelstein reaction. Okay. So what is the product? Halogen exchange means iodopropane or one iodopropane will product. The product is CH3 bond, CH2 bond, CH2 bond I. One iodopropane. So the first option. See here the conversions A. First reaction is elimination reaction, loss of HBr. The second one is anti-Markovnikov addition reaction. The third one is Finkelstein reaction. Finkelstein reaction. The final product is 1 iodopropane or iodopropane. Okay. So the first option is correct. So conversions are very, very important. Now let's see that 11th question on mixture of ethyl acetate in aqueous sodium chloride. Ethyl acetate. So write just ethyl acetate CH3 C double bond O bond C2H5 ethyl acetate. This ethyl acetate in either in acidic medium or in basic medium. It can be hydrolyzed to give acid and alcohol will produce. But in the ethyl acetate in the presence of NaCl, sodium chloride, aqueous sodium chloride solution, NaCl is neutral. NaCl is neutral solution. pH is equal to 7. So no reaction. So the resultant, while you are adding that sodium chloride solution, then ethyl acetate after that resultant solution also present the same only. So the answer is ethyl acetate plus NaCl only will be present in the resultant mixture. The resultant ethyl acetate cannot be hydrolyzed. Ethyl acetate, do you want to hydrolysis of ethyl acetate? Then either acidic medium or basic medium is required. Ester hydrolysis in acidic medium is first order reaction. Ester hydrolysis in basic medium is a second order reaction. Okay. So that ester is present in aqueous NaCl means the resultant solution is also same composition. There is no reaction. So the first option is correct. Okay. This kind of questions also very, very important. Let's see for next question. 12th question, dear students. It is also very easy, and just it is the applications of different named reactions. The first one is free radical substitution reaction. The first one, CH3 bond CH3 reacts with bromine in the presence of sunlight, forms ethyl bromide CH3 CH2 Br, or 1 bromoethane is free radical substitution reaction. The first one. Now this bromoethane treated with lithium aluminum hydride. This is A, is treated with LaH. Lithium aluminum hydride is reduction reaction. Reduction. So alkyl halides. Alkyl bromide is converted into alkane. The product is CH3 bond CH3. Again ethane came. That is B. Again this B treated with bromine in the presence of sunlight. The product is again ethyl bromide will come CH3 CH2 Br. This is C. This C reacts with sodium metal in the presence of dry ether. Dry ether means Wurz reaction. So Wurz reaction, what it is Wurz reaction? 2 moles of ethyl alkyl halides reacts in the presence of sodium metal, forms higher number of alkanes. Here 2 carbon atoms are present. The alkane is 4 carbon atoms. CH3, CH2 bond, CH2 bond, CH3. N-butane is the product. or butane. N-butane or butane is the product. So the answer is first option is correct. Okay. So conversions. First one is free radical substitution. Second one is reduction. Alkyl chlorides reduce in the presence of LaH or sodium borohydride and forms alkanes. Again, free radical substitution reaction. After that, Wurth reaction. Okay. Clear, students? Let's go for next question. This question is very, very important. 13th. Let's see the 13th question. Identify X, Y, Z in the series. See, the first one is ethyl iodide treated with alcoholic KOH. Loss of HI, hydrogen iodide. The product is CH2 double bond CH2. Ethene. Okay. See here, identify X, Y, Z in the following series. Not only identify Z, final product. What is Z? They are asked. Okay. Now this reacts with bromine. Addition of bromine. Addition reaction. Okay. Then we are getting CH2 Br bond CH2 Br 1,2 dibromoethane. This 1,2 dibromoethane is treated with KCN, potassium cyanide. This is excess. Potassium cyanide excess means we need to take around 2 moles. Then it undergoes nucleophilic substitution reaction, produce CH2 CN and CH2 bond CN. So the answer is third option is correct. Okay, carefully listen the 14th question. In nucleophilicity order in polar aprotic solvents. Okay, here it is very, very important. This here two important questions I want to discuss. That is nucleophilicity order for SN1 and SN2 reactions. Okay, for SN2 reactions, polar aprotic solvents are favorable. Polar aprotic. Already we are studied in first PC. Solvents are two types: protic solvents and aprotic solvents, and polar and non-polar. Among these polar aprotic solvents, aprotic solvents favors SN2 reactions, and high concentration of more concentrated nucleophiles are required. Now, in this SN2 reactions means polar aprotic solvents. For SN2, nucleophilicity is directly proportional to basic nature or basicity. Okay, here that nucleophiles are, what are the given nucleophiles, dear students? F minus, Cl minus, Br minus, and I minus. Okay, see for this case, first we will write this conjugate. These are the bases. It's conjugate acids. It's conjugate acids. HF, HCl, HBr, and HI. Now acidity order. Acidity order is HF is less acidic than HCl, and then HBr, and then HI. Okay, among these HI is more acidic. It is acidic. More acidic means its conjugate base is weak. Okay, this F minus is conjugate strong base. Conjugate base is strong. Okay, now that basicity order is directly proportional to nucleophilicity order. That is nothing but F minus, Cl minus, and then Br minus, and then I minus. Okay, now let's see One more important thing is for SN1 reactions. SN1 reactions, polar protic solvents are required. Polar protic solvents. Polar protic solvents means like water, ethyl alcohol. These are the polar protic solvents. So in this polar protic solvents, the nucleophilicity is inversely proportional to basicity. Inversely proportional to basicity. This is that for SN2 reactions. Now in the same way for SN1 reactions among the given nucleophiles F minus, Cl minus, Br minus and I minus, the nucleophilicity order is reverse. F minus is less than Cl minus and then Br minus and then I minus. The last question, this kind of questions they are asked. So both are very, very important. See, for SN2 reactions, nucleophilicity is directly proportional to basicity. Okay. For SN1 reactions, nucleophilicity is inversely proportional to basicity. Okay. Or basic nature, not basicity, basic nature. Okay, let's go for now 14th question. Answer is second option. This is the correct nucleophilicity order. Polar aprotic solvents means you have to remember SN2 reaction. Nucleophilicity order is directly proportional to basic nature. Polar protic solvents. Polar protic solvents is nothing but SN1 reactions is inversely proportional to basic nature. So these two important conditions, if you are kept in your mind, then it becomes very easy. This kind of questions we can solve very easily. Okay. So they won't mention, sometimes they will mention, write that correct nucleophilicity order of SN1 and SN2 reaction. That case it's very easy. Sometimes they will give like this. That time we have to identify whether the nucleophilicity order is belongs to either SN1 or SN2. Okay, that is very, very important. Okay, let's go for next question. 15th question. Seventeenth question, sorry, 15th question. Let's see. Addition of hydrogen iodide. Addition of hydrogen iodide is nothing but Markovnikov addition reaction, dear students. It is Markovnikov addition reaction. Markovnikov addition reaction means forms more stable carbocation. Forms more stable carbocation. More stable carbocation intermediate. Okay, let's see that. First you have to add H plus ion. CH3 first by the addition of H plus. Here this double bond is present. Now this double bond is migrating towards here negative charge and here positive charge will comes. This hydrogen will be added at more hydrogens containing double bonded carbon. Then the intermediate forms stable tertiary carbocation. Okay, the next step we have to add I minus. This I minus added at tertiary carbon. Now the final product is methyl, 1 iodocyclohexane is the product. Second option is correct. Okay, so this kind of questions also very, very important. Okay, let's go for next question. 16th question. So the first one is diazotization reaction. Aniline reacts with NaNO2HCl. At 0 to 5 degrees centigrade, low temperatures is nothing but diazotization reaction. Reaction. Okay, it's very clear. Now, what is the product? The product is benzene diazonium chloride N2Cl. This benzene diazonium chloride treated with copper chloride. Cuprous chloride means it is a Sandmeyer reaction. Then the product is chlorobenzene. Okay. Now this chlorobenzene, this is X, this is Y. This chlorobenzene treated with methyl chloride CH3Cl in the presence of sodium metal and dry ether is known as Wurtz-Fittig reaction. Wurtz-Fittig reaction. Now the product is loss of 2 NaCl. The product is toluene. The final product is a toluene, dear students. So the answer is toluene, first option. This kind of questions are very, very important. See, what is this given conversions? These all are named reactions only. That's why we have to remember the total named reactions. In your textbook, around 35 named reactions are present in second PUC. And first piece also 10 to 15 are there. So total we have to remember in our mind immediately. We have sharp idea is very, very important. Whenever we are asking one named reaction, immediately we have to tell. Then only we can solve this kind of conversions from organic chemistry very easily. And basic idea also very, very important. Which of the following undergoes replacement of chlorine by OH minus ions? Replacement of Cl minus by OH minus ion. Merely warming with sodium hydroxide. So which will, it is nothing but nucleophilic substitution reaction of aryl halides. Aryl halide is directly proportional to electron withdrawing group, means minus I group on benzene rings. So that's why which can be undergoes very fastly in nucleophilic substitution reactions. So the nucleophilic substitution reactivity order is 2,4,6 trinitrochlorobenzene is very much more because more minus I groups. That's why it is more reactive in nucleophilic substitution reaction. It can readily produce just sodium hydroxide if you are added, then immediately it produce 2,4,6 trinitrophenol. It is nothing but picric acid, it will forms very fast. Next, this compound, 2 NO2 groups are present. The next one is 1 NO2 group is present. Reactivity order. Next, chlorobenzene. So aryl halides are very less reactive in nucleophilic substitution reactions. When the aryl halides having electron withdrawing groups at ortho and para positions, it decreases the electron density at ortho and para positions, then the nucleophilic substitution reactions rate will be increases. So that more reactive in nucleophilic substitution, this is nothing but SN, nucleophilic substitution reaction of aryl halide. So that's why the fourth one here NO2 group is present. So it is a more reactive. Okay, let's go for next question. 18th question. 18th, it's very easy. See here, FeCl3 they gave. It is wrong, ma, dear students, not FeCl3. CuCl. Then the X is Sandmeyer reaction, first one. The X is chlorobenzene. Again, this chlorobenzene treated with chlorobenzene in the presence of sodium metal means Fittig reaction. Fittig reaction, the final product Y is biphenyl. Y is biphenyl. C6H5 bond C6H5. This is third option is correct. Okay. Now, 19th, fluorobenzene can be synthesized in the laboratory. How can we synthesize fluorobenzene? Because the fluorobenzene synthesis, that name reaction is known as Bald-Seaman reaction. First, aniline, benzene ring has NH2 group, it is called aniline. This aniline treated with NaNO2 HCl is known as diazotization, forms N2Cl, is treated with HbF4, forms N2BF4, benzene diazonium tetrafluoroborate. See, aniline on diazotization followed by heating with Hb reacts with HbF4 on heating produce fluorobenzene plus N2 plus BF3. Okay, so fluorobenzene we can synthesize from aniline. First diazotization on treated with HbF4 on heating, then we are getting fluorobenzene. Second option is correct. Okay, let's go for 20th question. See, this conversion is very, very important. How can we synthesize from nitrobenzene to 1,3 bromofluorobenzene? Okay, otherwise 1 bromo, 3 fluorobenzene. How can we synthesize this? First, this NO2. Okay, this NO2 we have to convert it into NO2 we have to convert it into fluorine. How can we convert NO2 into fluorine? This NO2 we can convert first N2. First we have to convert into NH2. Then we have to convert into N2 plus Cl minus. Then we have to convert it into fluorine. This at here at meta position we have to attach bromine. Okay, first this is 20th question. First we will attack bromine only, because after that NO2 group we can convert into fluorine very easily. This NO2. This NO2 is a meta-directing group. Minus I group is meta-directing group. Okay, students, it's very clear. Meta-directing group. So first we have to do electrophilic substitution reaction, bromination, Br2 in the presence of FeBr3 is here electrophile is Br plus. Now we'll get meta-nitrobromobenzene NO2, and here bromine will present. Next step, what it is next step? This NO2 we have to reduce. The reduction is takes place in the presence of SnCl2. SnCl2 by HCl, then this NO2 group will be reduced. It produces nascent hydrogens. It will be reduced into NH2 group. NH2 bond Br. Here Br is present. Now it is treated with NaNO2 plus HCl. Then it produce converted into N2Cl. Bromine is as it is. Then it is treated with HbF4, forms N2BF4 is the product. and at meta position bromine as it is. This is on heating produce the major product is fluorine and bromine. Okay, so don't confuse. Here bromine is upside they gave, means NO2 cannot be converted into bromine. Here what we did, this NO2, first this NO2, first we did bromination, NaFeBr3. Then because of NO2 group is meta directing group, the electrophile will be attacked at meta position. Then bromine already came at third position. This NO2 we are converted into fluorine finally, followed by reduction, reduction followed by diazotization, diazotization followed treated with HbF4 on heating, then that NO2 group finally converted into fluorine. And what is the position of bromine and fluorine? 1 and 3. 1, 2, 3 positions. Okay, this is the final product. So what are the steps we are followed? Bromination followed by reduction. This is reduction. Next diazotization. Diazotization treated with HbF4 upon heating. So the second option is correct. So the second option containing reagents are very correct for the conversion of nitrobenzene into 1, 1 bromo 3 fluorobenzene. Okay, this kind of questions also very important for JEE and NEET. Okay, let's go for next question. It is direct NaCN EMF. Okay, Na plus and Cn minus. This reaction is inversion product will forms. Here Sn nucleophilic substitution reaction. Here benzene ring also having attached iodine is present, but the halogens are attached directly to the benzene ring. They are less reactive in nucleophilic substitution reaction. Okay, the final product is iodine, and here CH2Cn will comes. CH2Cn. So the fourth option is correct. Okay, let's go for next. Question 22. SN1 reaction order, SN2 reactivity order they asked. SN2 reactivity we know very well. Primary alkyl halides are more than secondary and then tertiary. So among that, this is primary and secondary and tertiary and methyl chloride. So fourth option is correct. Okay. Now 23, the alkane that gives isomeric alkyl halides, one isomeric alkyl halide on photochemical chlorination is, let's see the first one. 23, propane. Propane on photochemical chlorination, Cl2 in the presence of sunlight. It has two types of carbon atoms are present. This is A and A. This is B. It produces two products. Already this kind of questions earlier only did. That's why directly I am writing how many possible products. What are those two products if you want means 1, 2, 3 and here chlorine and here chlorine. 1 chloropropane and 2 chloropropane forms. First option that is. Let's see the second option. 2-methyl butane. Here this is nothing but isopentane. 2-methyl butane. It contains how many types of carbon atoms are present? Carbon containing hydrogen atoms are present. This A, methyls A and A same. This is B and this is C and this is D. So it produces 4 products, 4 monochlorinated products will form. 4 monochlorinated products. Okay, next neopentane. Neopentane. Let's see the third one. Neopentane. Neopentane means CH3 quaternary carbon is present. One carbon is attached to 4 methyl groups. See, upon chlorination in the presence of sunlight, only one kind of product will form. This is A. This is similar all CH3 groups. So wherever you have to replace hydrogen atom can be replaced by chlorine, will produce only one kind of product only. Cl. Okay, here only it will be produced. Here also same. That's a one product. So the answer is neopentane. Neopentane. Now isopentane, let's see. Isopentane is nothing but 2-methyl butane only. Isopentane. 1, 2, 3, 4. This common name is isopentane. Isopentane is nothing but 2-methyl butane. So it produce how many products? 4 products. Already second option and fourth option. Second option is IUPAC name, fourth option is common name. So the answer is third one. Okay. So this kind of questions also very, very important. So main for organic chemistry, main clean important thing is observation important. What is the given question, how to solve, and what is the proper answer. If you knows that, we can solve this kind of questions very, very easily. Okay. Let's go for next question. Okay. Which alkane gives two isomeric monochlorides on photochemical reaction? See here, the 24th question, the correct answers are two. One is butane and propane also. Just now only ethane. Ethane, CH3 bond, CH3. Only one kind of carbon atoms are present. A means one product. One product. Next, butane or N-butane. Butane or N-butane. 1, 2, 3, 4. This is A and B and this is also B middle and this is A. This end because it is symmetrical. This type 2 carbons are one type and this is also one type. So it produces 2 products. Next, pentane. Pentane can produce A and carbons are similar. Next B and C.